available publicly. So you can just go to OpenAI.com, OpenAI. My God, by the way, how it's called? Yeah, OpenAI.com, and then you can just sign up for the beta. The only problem that you might encounter is if you are in countries where it's not available, you have to find your way to get in. I'm not going to talk to you here about how you can get in. But yeah, it's really fun. By the way, if anybody here have used any kind of open source replacements for GPT-3, it'd be really useful to hear your feedback. Feel free to type in chat if you ever used anything like GPT-J, GPT-Neo, or something like that. You can click on chat and just type in there your feedback. Dilia and Oleg, have you used big language models? What was the biggest language model you ever used?
You know, like I'm a bit probably over optimistic about interpreting language models, and I got a chance to perform probing studies on Megatron, which has been recently trained in Hugging Face, if I remember correctly. What was interesting with it is they had lots of checkpoints, so I was able to compare the earlier stages of model where it just started training with the ones more similar to the model we finally are using. And well, the problem here was just I was unable to run it in Colab, so it took me time to find the proper machines to run it. But it always feels like, I don't know, living with an elephant in the room. I mean, it just is super huge, and just this fact impresses you.
I haven't used by my own hands some really big models. Unfortunately, this is, I don't know, maybe just a bit strange, but it's okay, I think. And I've used Russian GPT, and for some also paraphrasing text expansion tasks. And I see in the comments in the chat that there is a command that somebody uses it usually for university assignments for paraphrasing and summarizing. That's interesting. Have you trained it by yourself or just use as this?
It's a good question.
I mean, what model is for summarizing is used? Summarization task. Maybe that's it.
I'm not sure if I can spell it correctly. I'll try it to say Basarai. Feel free to correct me if I called you wrong way. Did you try to fine-tune your GPT-3, or did you use the pure one provided by OpenAI? He haven't trained it himself, but he used themselves. Okay, but he used pipelines that already present in the web. Jill, what was the largest size of BlenderBot we used in Dream during Alexa Prize 4?
90 million parameters. 90 million parameters.
Just millions, not billions, just millions.
Just
so we are really
3 them, so this is millions, I suppose. Yes.
I heard that the largest model that Google shipped like a couple of weeks ago, it had like 240 billions of parameters, or 280 billion parameters.
That's a lot of resources, of course.
Well, it's Google. If they can do it, who can?
Okay. No, that's good.
Okay, so it's 7:08 p.m. I think we can more or less start. It's our very first community call in 2022, and I'm really happy to hear that, to read that. So yeah, this is our very first community call in English in 2022. we are getting back to our tradition for running community calls. So we've got a lot of amazing feedback a few months ago how to do these kind of things. However, and I think some part of conversation we started here is one of the results of what you learned from members of those community calls a few months ago. So today we will have a few things to talk about. One of them is announcement of our DeepPavlov Dream. And we will also talk about DFF, our framework for building scenario-driven bots and skills for DeepPavlov Dream. We won't actually have a big live conversation about building Russian version of Dream. Still, we are planning to build a Russian version of DeepPavlov Dream in addition to the English one that is available at the moment. And what we think about is about having some sort of hackathon where we could grab some developers and build together in an online form or something like that, useful skills for Dream. So maybe we could build something like that for English as well, where you would just, like come and try our developer tools and build skills. I don't know, maybe reminders or some things that connects to your Gmail calendar or something like that. It could be very easy, very simple. It will be useful for the community. It could be also useful for us, and we could get some real feedback from how good or how bad our dev tools are. And in general, it would be a useful way to learn about DeepPavlov Dream in practice and contribute to open source. So with that said, a few words, and then I will pass to Diля. So the reason why we build DeepPavlov Dream is we believe that if you want to build bots, big bots, you eventually will have to build many bots representing different kinds of interaction between customers and organizations. So obviously there is idea that if you want to build a big end user bot, AI assistant like Alexa or Google Assistant and so on, you need to have multiple apps of sort that will do different functionality, and that's where multi-skill architecture makes a lot of sense. And that's how they're built. Siri, Alexa, Google Assistant, they all have this notion of skills. However, in our conversations with customers and based on the conversation we had with our friends from Microsoft Power Virtual Agent platform, turns out organizations want to build bots that represent those organizations. Imagine something like Starbucks or Erica, which is a virtual assistant provided by Bank of America and so on. And those bots are also complex. And while they don't have a huge ecosystem of services provided by Google, Amazon, or the like, they still have lots of different tasks belonging to different domains. And it's our belief, and it's also our experience, that if you want to build multiple domain experience within the single bot, it is much easier to build them in parallel by different teams, rather than trying to build everything as one monolithic solution. And that's why we decided to invest heavily into multi-skill architecture. And that's why we also are building this entire DeepPavlov conversational AI stack, where we have library and annotators with models that will enable developers to build general NLP solutions. Then we have this engines level where we support multi-skill AI assistants with DeepPavlov agent. And we have this brand new scenario-driven framework called DeepPavlov DFF engine, or DF engine here, which was born during Collective Prize 4. We have this SDK that enables you to run single skill bots, if you like, on top of DF engine. So in a way, you can think of this way. So yeah, not this way, but this way. And then we have platforms. One is DeepPavlov Dream, which is a platform for building multi-skill AI systems. And then there is DeepPavlov DFF that allows you to run smaller single-skill framework-based bots. And finally, last but not least, we have the level of developer tools, where we are building DF Designer and DF Dashboard, and we will have a couple of more things to be built and provided to the community. And at last but not least, all of the things here are open source. All of the things here are provided under very friendly licenses, Apache to the top. Except DF Designer, the current iteration is GPL3, but the new iteration that is currently under works is written from scratch, and it will be under Apache to the top as well. So all of that is available for free. Anybody can grab it, anybody can bring it their home and build on top of it. And we encourage you to do that. And with that, I'm passing to Dilara, who was a team lead for Alexa Prize for social bot called Dream. We love this word, Dream. And who is now our technical leader driving DeepPavlov Dream AI system platform. Dilara, the stage is yours.
Thank you. Just a second. Give me some. Okay. Oh, sorry. Thank you. Today I'm gonna tell you about our DeepPavlov Dream and its future directions that we are going to develop. So let's start from the from what DeepPavlov Dream is. So basically, DeepPavlov Dream was originally a social bot that was a multi-skill social bot that supported chit-chat conversation on general topics. So on any topics that Amazon Alexa users wanted to discuss. And DeepPavlov Dream was developed for the Alexa Prize Challenge that was conducted by the Amazon. And we participated as a Moscow Institute of Physics and Technology team, Dream. And we have developed during 2 years these multi-skill dialogue systems. And after that, we decided that this is not only a social bot, but it also could be a platform, and it will be a platform, open source platform for dialogue systems development, because it is already have a lot of different very important components that could be reused by all other people that who want their own AI assistant. So the main use of current community call is that we have finally officially open sourced our social bot. So previously in July, we have ended our participation in the Alexa Prize Challenge in the July of previous year. And we spent almost half of the year just making some refactoring code, and now we are ready to open source it and share with other people as a platform for dialogue systems development. And the code is available on GitHub, and also you can visit our website. And by the way, there is also a demo for our social bot that is available on our demo DeepPavlov AI website. So let's start from the description of the DeepPavlov Dream social bot and platform. And if some of you have already seen my maybe seminars or other videos on our channel on the YouTube, so probably you will not be very interested in the Alexa Prize Challenge and the main components of the Dream social bot, but later I will give you some information about our development and what we are going to do during this year, for example, and probably it will be very interesting for you. So let's start with the Alexa Prize Challenge. This is a university competition of the social bots that can talk on the different topics, on the daily topics. And this is a challenge by Amazon. So the main the main aim of the Alexa Prize Challenge is to develop a chatbot that can talk with the user for a long time and achieve a very high rating. And the rating is the value, floating point value from the user that user wants to, that denotes how much user wants to talk with this social bot again. So this is the main metric of this competition. So this was the reason why we were very, very focused on the conversation with the users that will engage them, that will cover some topics deeply, and will conduct this conversation very interestingly for the user. So this is the architecture of Dream Social Bot at the end of the Alexa Prize Challenge 4. And almost all of these components presented here are now available as the components for the Dream platform. Some of them were closed APIs, not closed, but private APIs. So some of them are not, for example, Cobot by Amazon are not available, but all other components are presented in the current version of Dream Social Bot and Dream platform. So mainly the architecture of the Dream Social Bot is based on the architecture of DeepPavlov agent, because DeepPavlov agent is an open source framework that we have used to build our social bot to orchestrate all of these multi-skills components. So basically there are several main parts. The first one is annotators. This is the set of different natural language understanding components and knowledge extraction components that are used to annotate user utterance, user input. So we also have the dialogue state that stores all the information about the dialogue, information about the user, information about the social bot, information about all previous and current utterances, including their annotations. And skill selector is the component that that determines which skills will be called to try to generate some response candidate for the current context. So for the current user utterance that was annotated and the previous utterances. So it takes into account all this information and chooses the set of skills that will be called. So after that, there are those chosen skills. Just simply try for the current context, for the current dialogue state that they obtain. They're trying to generate those response candidates. So it could be 0 or several or one response candidate, but by each skill that was called. And we also have a lot of different skills of different origin. I mean, there are several template-based skills that uses, for example, thought filling for the generation of the template-based utterances, and also IML-based skills. We also have generative skills and retrieval skills, and that is more important, we also have a lot of scripted skills. This is the skills that we are making a focus in this social bot, because for the Alexa Prize Challenge, we had to make a social bot that will deeply discuss some very popular topics with these users of the Alexa Prize Challenge to make them happy, to satisfy them, to get high rating. So we had to generate a lot of different scripted skills, cover a lot of different topics that are presented here. So we use it for this DFF, Dialogflow Framework, about which we will talk later. And we also had some event-oriented skills. And after that, those generated response candidates just simply annotated with the models that will be useful to choose which of the response candidates is better, is the best to be given to the user. So the response selector, exactly the algorithm that chooses the final response among all the annotated candidates that will be given to the user as an output. So this is the main architecture of the social bots that is used in the Dream social bot, and also this is the main architecture of the Dream platform. So using this platform, you are able not only to add your own annotators, so you also can add your own skills. You can also change some logic in this pipeline, because it will be so it's somehow really customizable because of the multi-skill, multi-components structure. So let's start with a small overview, but it will not be very deep. If you want to find more information about it, you may firstly try to find out our technical report. That is very long paper about technical details of the Dream Social Bot. And also, there are several videos on our YouTube channel, where you can also find some more details about the AlexaPress challenge and Dream Social Bot architecture. So basically, we had a lot of different annotators, as I already said. We had, yes, sorry, we had several neural models, like for solving different natural language understanding tasks, like named entity recognition, sentence segmentation, like different classification tasks. And we also had several rule-based models, for example, finding some bad words in the user utterance. And we also had different APIs for classification from Amazon. And we also made, previously we had a lot more classification models, but then we understood that we have no so many resources for this task. And now we have, there is 3 models of the classification for the multitask BERT classifier, but now we have 7 in one. So this is like increasing very good component that helps us to save our resources. And I think probably we'll make some ready pipeline to be used for training your own multitask BERT classifiers in DeepPavlov. We also had a lot of integrations with knowledge bases, because this was the this is the main opportunity of the social bot to get a lot of information in some structured way. And first of all, of course, some entity linking to understand what are the current entity, what the current entity is in the database. Also extracting some knowledge about it, some relations and common sense relations also, and answering different questions using these knowledge bases. And this is all about annotators for knowledge base, and why we needed it I will talk a bit later. And after that, we are going to skill selector. So the main logic in the skill selector, except of some special cases when users, for example, offends a social bot, or when user wants some comment or something else very very rare intent, for example. Besides all of these situations, we just simply use the logic that is based on topics, dialogue acts, entities, and pattern matching, and we just simply choose corresponding closed domain skills. So what other skills do we use? I've just briefly discussed previously what skills do we use. So this is generally AML, different AML skills, a lot of different template-based skills. So the algorithms are originally based on the dialogue acts, on the topics, intents, so entities. So it's like all the annotations that we had previously get from the user utterance. And this logic is based on these annotations, and the responses are usually generated as like from the template based to using slot filling. And that's all. There are different template-based skills in our social bot. They could be of general domain, of closed domain, of event-oriented. So it means closed domain and general domains, like closed domain when it can talk just on some topic, and general domain when it can talk on any other topic. So we also have several skills that use template-based logic with external services. For example, weather skill that extracts weather from the external service open weather map. And also we have the retrieval skill, and even we have generative skill this year finally, as all other teams also do. So As I previously already said, that we had a focus on the scripted skills because they provided us with an opportunity to deeply, in details, discuss one particular topic that that the user are interested in. So it was hard to. The first year we have developed a lot of different scripted skills, but by hands. Every developer did it by himself, and it was very distracting because it's hard to, the code became bigger and bigger for each skill, and the logic was much more difficult from time to time, and it was hard to understand what other developer have developed in his skills. So we decided that we need some generalization, some structure, some framework, and this year, so previous year, actually. So one of our developers, Denis Kuznetsov, have developed the Dialogflow Framework that is open source and will be discussed today, I think, by Daniil Kornev. And this framework is used to simply, rapidly develop some template-based skills. So this is the Python-based framework, and it's very cool, it's very nice. It can be used by any developer of any level to just simply, fastly develop a social bot, small template-based social bot. So we also had an extension of this Dialogflow framework because we had a high opportunity of usage of knowledge graphs, and as I previously said, we had used a lot of different annotators with the knowledge graphs, and one of them, this is the Wikipedia linking, and we had a lot of Wikipedia dumps, and we wanted to use this knowledge somehow, and the idea was to insert in our dialogue, in the dialogue with our social bot, the discussion of this Wikipedia pages structure. So we have just these Wikipedia pages, and we have just discussed it by each point, and this was cool. So we also used the generation skill, as I said, and this is a very new thing that was changed from the previous Alexa Prize Challenge 3 competition, because it brings us a lot of new possibility to converse with the user. So it generates a response based on the conversational history and knowledge that was extracted from annotations, for example, news, movie plots, or Wikipedia facts, Wikipedia large information. So we used Parlay Blender model, 90 million parameters, and we have fine-tuned it on topical chat dataset that is also open source. And you can see the results of this model that we use. So it probably generates some information that is really somehow related to the information from the knowledge and to the context, of course. So now we are just proceeding to the response selection parts. So there are also a very difficult logic, but basically there are two prioritization algorithms. The first one is the general. So if you have some special requests by the user, you're accomplishing these special requests. If user wants to switch topic or user wants to pick up the particular topic, you're just simply accomplish with this request. And after that, we just used the general priorities to prioritize, to split all the candidate responses into several groups. And we also wanted to be able not only to prioritize scripted skills, as we wanted to discuss deeply some topics, we also wanted to be able to listen to the user, to hear the user. So we also had a special rule that is here. So in those cases when the user intent requires some particular action, we are just simply choose the candidates with the required dialogue act. For example, if we have, if user wants us to give him our opinion, so user requests opinion, it is better for the social bot not to ask something, but to give him those opinion, his opinion, and therefore this condition just simply gave us an opportunity to stop the script that we have previously followed and to satisfy the intention, the request from the user. So what are these general priorities? In the absence of all these special cases, we have those general priorities that we prioritize scripted skills. So if this skill can continue the conversation on the next turn, and it was previously active on the previous turn, so this like script continues his skill continues his script. So we just simply give him this opportunity because there are no special requests. And if this is the skill that can continue on the next step, but it was not active on the previous step, it has the second priority. If it also contains entities from the user utterance, it has the second priority. But if there are some skills that cannot continue on the next step, but they also have these entities from the user utterance, they have the third priority. And after that, there are all other scripted skills and all other not scripted skills. So what does it mean? That means that we generally prioritize scripted skills to conduct those dialogue using this script that was already in the process. And if you do not have this skill that is in the progress, we just simply prefer those utterances from skills that will be able to continue the conversation and that also has some entities from user utterance. So we just simply think that probably these utterances are somehow related to the user utterance and they also will be able to continue. So this is a very good choice. And if there are no those utterances, we just use candidates that have the same utterance entities, but probably cannot continue on the next step because maybe they are more related than others. And after that, the next priority goes to any other scripted skills. So this is very, I think, simple logic for this response selection multi-skill AI assistant that can cover a lot of different topics. So about different features in our social bot. So basically it has topic recommendation that is based on the rated personalities, but it has some disadvantages, like we have the fixed number of topics and we are now want to make it better. So what are our current goals of the team development for the future? So first of all, we are working on the dialogue rounding. What does it mean? It means that the social bot should understand what happens in the dialogue. So it should not only understand what is happening in the dialogue, but also explain to the user why the decision of the social bot, why the response by the social bot was like this. And this brought us to the necessity of the usage of the goal-aware dialogue management. So to understand what happens in the dialogue, we need to understand what were the goals of both participants of the dialogue. We also, if you're talking about dialogue management, one of the main feature when we're talking about chit-chat conversation, I mean on the general domain, we need to be able to offer some topics for the conversation that will be interesting for user. And to make it, to give him a recommendation of the dialogue subject, we need to know some information about him. And we need to not only know the information that he said directly as the personal information, but we also need to be able to extract this information from the dialogue and to store it appropriately somewhere in the dialogue state. So for that, we propose and we are trying to use the knowledge graphs for personalities, for the user base, for the user personality and for the social bot personality also. And another direction is about scripts. So it's really hard to, not hard, but time consuming to cover a lot of different topics with the scripts. So it also, we want to have different scripts for the same topic to make it more interesting for the returning users. So we want to somehow achieve this auto script generation approach that we're working on. And we also want, even if we do not have still some device for using our social bot, and the Dream social bot platform is just about building the social bot. There are no some devices for that. We still want to have some multimodality in our social bot, because to be used in the messengers, for example, you have to be able to proceed with the voice messages, with the images, with videos. So it's really necessary thing in our current situation with the messengers. So we want to work on the multimodality also. And there is also news about just, it's like more about Russian community, but now we are starting to work on the Russian baseline for the Dream social bot. Of course, it will not have the same very big amount of the skills of the components. It will be a baseline, but still this will be able to talk on the different topics in Russian language. So probably it will be a good example how to start from the beginning and how to develop the social bot in your language, any language that you want. So just a bit in more details of different directions. First of them, this is the goal of dialogue management. So we, for example, if you have to denote, to determine the goals in the conversation, we suppose both of participants, the user and the social bot, have their own goals in the conversation, and probably there are some global goals and local goals. And probably global goals are those that user came with and the social bot came with, and the local goals indicate some goals of the user, of the social bots, that can be completed in several steps. So it's like get recommendation of something, for example. So it's not the one-line dialogue act or intent, but it's like a goal for several turns in the conversation. And they can be changed from time to time in the conversation. And there's goals, there are also goals of the user and of the social bot. And this is the challenge, the main challenge now for us to implement this understanding of the user goals and tracking these goals and accomplishing the user's goals also. So the next part is about personalities and recommendations that is related to the also to the goals and the dialogue flow. So they depend they depends on the social bots and the user's personalities, on their personas, preferences, etc. So we propose to store this personality, that is some preferences, main information, recent events that happened in their life, some life goals and plans for this conversation, particularly as a knowledge graph. And we also want these topic recommendations for the discussion in the dialogue to be based on these personalities, so to use this knowledge graph. And this is one of the reasons is that we think that the user's goals and probably the social bot goals characterize the personality. So I think this is all from me today. Thank you for your attention. You can ask questions, I think, now. There is a question in the chat that is response selector connected, related to skill selector pattern. So they are different components skill selector and response selector. And as you know, skill selector can be just a bit more rule-based because it can choose a set of skills, so more skills that it could be needed. So the response selector also takes into account all this information from the chatbot, from the user utterance, annotations, and also annotations of the different response candidates. So I think response selector is much more complicated than skill selector.
Dilia,
Yes.
I think it could be, another question about multimodality. I think before answering that question, addressing that question, you could probably go share github.com/deepnews/dream and explain things a little bit in visual form.
You mean?
Yeah, just open our GitHub.
Okay.
We talked about Dream for a year and a half now, I think, and finally this thing is available to the general public, so let's just showcase it.
Yeah, okay, let's see here. This is our github.com, deepmeet Dream. This is our main repository for our Dream social bot platform. And as you can see here, there is something really similar to the structure that I showed you as a Dream social bot architecture. So we have some folder with annotators, a folder with skills, we have the response selectors, we have skill selectors, but also we have some models and services. They have been used as the separate containers, and some, for example, skills could send them requests. So, and we also have the main folder that we needed here. This is the assistance. This folder contains different distributions of our social bots. So we have the folders for the DP social bot, different versions, and we also have Dream social bot folders. So we can see here that there are different YAML configs that could be used, that should be used for the social bot building and using. So there is also pipeline that denotes how the components, what components and how components will be called in this pipeline, and the information how to use all this system, how to build it, how to talk with it is presented in the main README. So probably we are just still works on the special read the docs documentation for the DeepPavlov Dream. So if you want, if you have some questions about DeepPavlov agent, there are already as they read the docs documentations. So and for the DeepPavlov Dream, we have those information. So different distributions that we have description here. And we also have a quick start information how to build the social bot. We also provide a very nice feature that is usage of proxy. So we have our social bot, Dream social bot, raised on our own servers. So if for those of you who wants to build the social bot on your own computer, but you have no so much resources, you can try to use this proxy YAML. There is also information how to use it with proxies. So this is main components. These main services are raised on our servers, and on your side will be just Docker containers that send requests to our servers. So probably there are also another information how to talk with these social bots, and also information about this proxy in details to understand what is it, how does it work. There is also a more detailed description of the components, not description, but some information about those components presented in our social bot with the information of the requirements that are used for each component. And each component for you to understand is the separate Docker container. So we have this container paradigm to be used as the part of the DeepPavlov agent. So we have the DeepPavlov agent framework that orchestrates all these different components, all different Docker containers. So I think this is the all information that we have. There's also license. You can use it as you want. And there is also some links if you will use it. So probably it will be better to maybe just cite our papers. Thank you very much. So we have questions here in multimodality. What are your goals? Is it hateful memes classification for making platforms safer? I hope no one will send us hateful memes, but probably yes. I don't know. Just for now, we have already discussed today what the multimodality is for different developers, and the question is correct that we have different understanding of the multimodality between us, and we are trying to figure out which one will be our aim. But I will tell as from the DeepPavlov dream side, I think in our terms, the multimodality is about understanding or ability to proceed these images, and probably understanding what is on these images, in these images, maybe like about image captioning, to understand what is the information is presented in this picture, and proceeding this image captioning, understanding that this is about image and not just simple text in from the user, but the description of the image. I think for the first steps, it will be like, yes, with images.
I think we can also talk a little bit about the multimodality skills. So in short, we have got a government and industrial grant for the next 3 years to work on a few big research directions. One of those research directions is actually multimodality. The vision for the time being is still being finalized. So there are multiple things that we want to work on. Some of them might include work for detecting people on videos and reacting to that, but that's still very early to talk about that. But I can give you one of the scenarios that I would personally love us to have implemented. So imagine when you have something like a Amazon Echo, something like that at your home, and it can actually see when you talk to it. So instead of you having to say wake word, you can just look at it and start talking to it, and it would react. You would not have to fit your phrases in those 20 seconds or minute or so which the system would wait for before interacting with you, because it would see that you're actually still talking or still thinking. And by doing these kind of things, we could make our assistant much more natural, much more user-friendly. So the opportunities for multimodality are really huge, but we're still finalizing our vision and our plans for the next 3 years. So if you do have any kind of ideas of what you would like to see in multimodality in DeepPavlov Dream, one of the things you can do is to join our Telegram group, which is actually, give me a second, I will share the link right in here. So if you've heard about it, not from the group, I mean about the chat, otherwise it would be crazy. This is the link that you can join. Otherwise, you can also go to issues here in DeepMeet/Dream, and you can just write down your concerns about multimodality. We would be really happy to triage your ideas. And by the way, we have here Alexei, who is leading our efforts in multimodality at DeepPavlov, and he will also be happy to hear your ideas and incorporate your feedback into our product planning and research planning. Okay. So, Denise, should I proceed with your talk, or are you feeling that you are capable of giving it on your own? Okay, so I suppose it's going to be on me. Okay, so let me talk about the DeepPavlov Dialogflow Framework. I think I've started showing slides somewhere. Yes. Okay. So what DeepPavlov, okay. So what DeepPavlov Dialogflow Framework is. So in general, when you want to build a skill for a multi-skill AI assistant platform, be that Google Assistant or Alexa or Siri or anything like that, you need to have a way to design and to run your skill. And there are different ways to do that. It can be finite automate based, finite state machine based, sorry, I was translating from my mind. It can be frame based, or it can be simple rules. It can be anything. I mean, you can also build FAQ skill, and that would also work. But usually you want to control the experience that your users have. And for all of that, you need some sort of a framework. Now, before we'll go further, it is important to clarify that Dialogflow Framework has no relation whatsoever to Dialogflow from Google. It's just we also design our dialog system in flows, and those flows are Dialogflow, so hence the name. Okay. So what Dialogflow Framework is? As a framework, it's a connection of multiple systems that you designed that work on different levels. So at the core level, which is strangely on the top, not on the bottom, we have a Dialogflow service. It essentially enables you to design your dialog flows, scenario-driven dialog flows, and run them in somewhere, whereas that somewhere can be some system. It can be a messenger, it can be some business application in a web, something like that. It can be some social bot. It can be conversational AI platforms. And the Dialogflow services itself, it can be run anywhere because it's a Python application, can be run anywhere. As I said before, it, like every other component of the conversational AI stack, is open source and publicly available, and has a friendly light of Apache to it also. You can grab it, you can modify code the way you want and interact with it and change it to your like. And it is also can be seen as a stack of technology by itself. It is designed in such a way that you have this engine, which supports designing your dialog flows in Python-based DSL, domain-specific language. Then you have multiple kinds of add-ons. And these add-ons, they are super useful. So they allow you to extend your system with components that you might find useful for yourself. For example, and I will talk about that a little bit later today, one of the add-ons allows you to do data collection and then use it collected data about your dialogues between your system and your customers to analyze user behavior. And later, optimize your dialog flows based on the data learned from this data. There are many other things that we want to build as Dialogflow add-ons, and like some of them are things like automatic graph construction, where you can, for example, have texts that show examples of how your users interact with your customer support, and then we can design a system automatically based on those kind of conversations. There are other things like recommendation, where you can recommend the next step in the design time. So when you're designing your scenario-driven skill, the system would recommend you the next step and thus help you to build more natural user experiences. And there are many, many other things that we plan to build as part of our Dialogflow framework. And for us, this is one of the biggest, perhaps, things we've shipped in the last year, alongside with DeepPavlov. We are super proud about it. So Dialogflow framework has engine, and this engine, as I said before, it's mechanism that allows you to run your Dialogflows. It's published on GitHub. You can pick it from PyPy, and it's also available. It has a lot of documentation around it, and it supports Python 3.6 and up. That add-on I mentioned before that collects data. Right now, I wouldn't say it looks super user-friendly, but it's automatically generated based on the data collected about dialogues, and it actually allows you to easily understand how your dialogues are actually working. And the thing is, it can allow you to see how one specific dialogue went into the system, but then it allows you to see all of the dialogues, so some of them. And that can give you lots of insights on how the system actually works when people interact with it compared to what you thought, how you thought people would interact with it. From my personal experience, as I was also participating in designing some of the skills for Dream, having this kind of insight would really, really help in designing systems faster and adapting to users quicker than usually you do it. As of add-ons have been designed combined with the entire framework in a Unix way paradigm. So each component is small. It is focused on solving only its own problem. And then there is a set of interfaces that allow you to combine all of those add-ons together to build a customized solution that would address your own needs. And that said, each of those add-ons has its own GitHub repository. It's also redistributed via PyPy and open license if possible. And you can also use it in a continuous integration for building your own custom solution on top of Dialogflow Framework. As I said before, that stats add-on that can collect data is example such of add-ons. And the data is finally saved to as a PostgreSQL or it's saved to ClickHouse, both of which are open source storage engines, storage systems for working with large data. Okay, one of the other cool components of the stats add-on is it gives a lot of other things that help you to see like what kind of nodes got more attention from the users and where people visit less or maybe don't get into those nodes of your Dialogflow at all. And that helps you to realize where you actually miss your users, where you don't get them at all, what kind of key areas they didn't actually reach, and thus giving you lots of insights how you should actually design the system and how you should adapt to users. Okay, so with all that said, we also have something called Dialogflow SDK. Originally, it was just a demo which we started building like half a year ago when we started building a visual designer for Dialogflow engine. But these days, Dialogflow SDK is a software development kit that allows you to grab engine, grab components, grab different add-ons together and build a complete solution for building a very simple, relatively obviously simple dialog system. The reason why it's relatively simple is simple in itself. Sorry for tautology. So if you want to build AI assistant like Alexa or Alice or something like that, you need an architecture that can run multiple skills at the same time. It can orchestrate those skills, can have multiple annotators running simultaneously in parallel. And for that, you need some complex orchestration. And fortunately, we have this thing. It's called DeepPavlov agent, and that's what powers DeepPavlov Dream. However, if you want to build a simple skill that would work for Alexa or Siri or Google Assistant or something like that, you probably don't need all the complexity of the DeepPavlov Dream platform. Instead, all you need is to have Dialogflow SDK and Dialogflow engine and learn a little bit is DSL, which is actually Python-based, and design your skill with it. So the annotators, we call them usually annotators in general, and we will call them DeepPavlov annotators later on. They will be shared with DeepPavlov Dream. Actually, things we have here, they're actually coming from DeepPavlov Dream. And the add-ons that we plan to build, they are focused on integration with raster, have few-shot and zero-shot policy models, and many other things. So we are really, really excited about the kind of things we will make available to you, and we can't wait to see what you're going to build with it. And what is a key distinction, perhaps, between DeepPavlov Dialogflow SDK and many other things you have in the market is we don't only build production-based systems. We're also doing applied and long-term research. And for that, we incorporate this research into our production systems. And Dialogflow Framework is one of the areas where we are specifically doing this kind of things. So one of the examples is a story where we can control dialog generation by diving into how dialog is generated in the large generative models. I cannot go right now into big specifics how it's implemented, but I can give a couple of examples. So we can say what the dialog act is, or what the intent of the user is, or what the sentiment or emotion of the user is. And based on that, we can generate responses of the dialog system automatically or semi-automatically in this case. And there are many other things that we plan to do, and that is only possible because we combine both the engineering team and the research team, and we work together, and by doing that, we enable fast innovation in DeepPavlov Dialogflow Framework. Okay, with that said, we're also working on the Dialogflow Designer. And Dialogflow Designer is actually an add-on. It's an extension for Visual Studio Code. And right now, the version we have in the public is available as a draw your based extension of Visual Studio Code. In it, you can visually design your conversation, and that conversation would be transformed into the DSL that we designed. Let me say a couple of things about this DSL. DSL, from my personal perspective, as someone who worked in the conversational AI area for the last few years, is, I believe, brilliant. We looked at all the other DSLs that we have in the market, and we looked at, for example, a DSL that was built by Dash AI folks, by Just AI folks, within some more specific, domain-specific languages designed around conversational AI. And what makes our solution different is it's Python native. You don't have to learn Kotlin or other things. You don't have to deal with JavaScript, God bless you. Instead, what you can do is use Python, and you can use a very compact structure, the one right here. So we have a flow. You create a name for the flow, and then you just make decision on how you would transition to the thing. Let me take a look if I zoom out. And I think I can draw a little bit, just a little bit. Yeah, all right. So this is it. So you create flows, and then you basically decide how you would go from one flow to another. You do that change using the transitions area, where you say which flow you want to go to, which node inside that flow you want to get to, and then you decide the condition. And conditions, they can be different. They can be and, or, and so on. And they can be different in terms of what kind of data you want to use. So for example, here, this condition is coming from one of those annotators. This is an annotator that identifies a dialog act or speech function in this particular case. So for example, user decided to clarify something from the system. They can use this clarification as a condition and then go to the next flow, to the next node in this flow, or to the node in a different flow by using that condition. Conditions, they endless. You can use emotion classification. You can use topic classification. You can use exact matching. You can use intent catcher for doing intent classification. Lots of different ways how you can control these transitions. And then if you're not satisfied with how these transitions can be done, you can write your own functions. So it will be absolutely up to you how you can control the dialog flow in the system. Then the other thing that is important is you can also control the response. So in these cases, response is simple, but don't let this simplicity fool you. In practice, you can use slot filling. So for example, you can go to a new node, and then you can write in condition that you want to find some slot. For example, user asked you that they want pizza, and they said that they want barbecue pizza. So you can identify that kind of thing, and then you can put that thing into the slot filler, and then you can put it into response and provide response to the user with the data coming from that slot filler. So for example, user says, I want a barbecue pizza. And for example, your chatbot is not just a bot that allows you to purchase pizza for the user, but can also say, are you sure you actually want a barbecue pizza? You had it for the last few days straight, so you maybe want to change it to something different. And so in other words, you can also control response generation by your own functions as well. So the other thing that is not shown here, I'm not sure if we have, we don't have a slide for that. But another thing is we also have something called processing. And processing, this is a crazy thing. When you are not satisfied with anything you've done before in this DSL, you can go to processing and you can overwrite everything for your like. And that would allow you to control the dialog very, very tightly, the way you want. At last but not least, what I would like to say about the designer is the opportunity for you to have recommendations. And that is something that we do as our applied research right now. And that is, if you want to design a dialog, we want you to enable design of the dialog, helping you to do it faster, because that's a quite annoying process when you design a dialog. I know that in the United States, there are people who have jobs called conversation designer, and that's not an application, that's a real job title, and people do their jobs. And they get good money because they know how to design conversations. So this is a really tough job. And in our case, what we are very passionate about is we are working on a system that can recommend you where to go at every single step. So this is a condition. This is what user says here, user. And this is what bot says. And we have built a recommendation system based on one of the approaches, which can say that after this node, user can do this, like condition option 1, option 2, option 3, and then it can recommend you how to respond. So users will be able to quickly design the dialog based on these recommendations. And these recommendations, they can be different. They can be based on speech functions, or in speech acts and dialog acts. They can be based on intents. They can be based on statistical data. And there's actually lots of ways how you can cut down times from imagining your skill to actually having it up and running in the system. So forgive me my passionate description of what the Dialogflow designer is and our DSL, but I really believe that this thing is brilliant because it's not in a strange language that you don't usually use in NLP. And it gives you right away access to all of the cool NLP libraries that you use in Python. And there are ways to statistically look into this code and find errors in it. And it's super, very easily manageable, and it's super extendable. And you are not limited to very basic things. You can put as many annotators as possible to the system. So this is a fantastic thing. And Dialogflow Designer and DSL that we built for Dialogflow SDK. Okay, so to the end, you have DFF as our engine. You can integrate in different kinds of systems. And you also have DevTools, which is our DF Designer. that enables people to end users like product managers, conversation designers to just build Dialogflow-based bots and skills on top of it. Here are a few links, and you can just use, I think, the second link to look at the source code itself, and the first link just gives you high-level information of what the Dialogflow framework consists of. Speaking of the talk, that's about it, I believe. I'm not gonna keep my ink annotators. Holy cow, I think we had lots of questions while I've been here. Right. Okay, is there anything, Dylan, is there anything I have to cover?
From the chat? I don't think
Yeah.
so. Maybe some other resources of the questions could be.
Okay, actually, right. So now that we discussed both Dream and DFF, I think one of the key questions is how is all related to Google Summer of Code. So some of you might know that last year we participated in Google Summer of Code for the very first time. And our participation in Google Summer of Code was fantastic. We've got 3 students in the very first year, and usually new organizations, they get just 1 intern in the year. One of those interns, she actually published her code in our DeepPavlov library. She built a valuable contribution in the form of a relation extraction component that we actually yet to use in DeepPavlov Dream. We have to put it there as an annotator, Dilia. We obviously have to check all the errors and so on and so far, but we should actually include it and make it available to the users because it's just one of the components you can use. In short, you can put a couple of entities extracted with entity extraction service, entity linking service, I'm sorry. And then the system would tell you in the phrase how those 2 entities are connected to each other. There are like 95 relations you can pick, and those relations are based on Wikidata, and you can use those relations to find information about what was said in the user's utterance. So this year, we have no idea if we're going to be in Google Summer of Code or not. We are still an open source organization, that's no problem. We will definitely apply for Google Summer of Code. But obviously, we have 0 control with that. So that's obvious thing, but I had to say that. And we've also published projects like we've done it last year. And those projects, they will relate to Dialogflow Framework, to DeepPavlov Dream, to our developer tools, and many other things. And just to give you some perspective of what could be built. It could be some new skill that would incorporate relation extraction and entity linking to do something in DeepPavlov Dream. It could be a skill. Or it could be some work focused on improving our Dialogflow designer. You probably have no idea how it was born, but Dialogflow designer, it was born as our research paper that we got published at Coding Workshop at MNLP conference last year. And at some point, one of the people from the community, Russian developer community, has stepped up and he started working on the designer. And he spent a few invaluable months with us improving it and making it a solid piece of work. That we were able to finally showcase at the MNLP conference and then AI Journey in Russia and other things. So designer is a big thing. Another thing that we wanted to actually build as Google Summer of Code, but we decided to make a different kind of internship instead, was DP Builder. It's a web tool. It will allow you to basically have a visual representation of everything happening in DeepPavlov Dream. You will be able to pick annotators you want, skills you want, design new skills using this DF designer, and basically train the necessary components and then build the whole thing and chat with it right into the same screen. So that's another thing that was one of the projects that happened last year, and it took a bit more than a Google Summer of Code, a full-time Google Summer of Code, yet it was a fantastic contribution. Or it can be, just giving you examples, it can be language model. It can be some, for example, one of the folks last year, he worked on multitask BERT. And this is crucial because right now, DeepPavlov Dream, it's a lot of resources. And we want it to be way less hungry. We want it to run on much smaller machines. Ideally, we want them to run on your local computers without any proxies. And to do that, we need to really make our models more distilled. We want them to eat way less memory in GPU and CPU. And for doing that, we need some technology. So one of the things that one of the folks did last year, he used multitask BERT paradigm and re-implemented a research paper. And then we used his work to build our combined classification annotator. Let me show you what I'm talking about so that you would not be seeing, you would not stay in the dark. Okay, so as you can see, by the way, Dream is my very first link in the browser. So we go to annotators, and here we have combined classification. So this combined classification is just one thing. And this one thing, it has 7 different annotators inside of it. Topics, dialogflow intents, emotion, sentiment, toxicity, and factoid classification. 7 different tasks. So it's 7 annotators in one. Again, emotions, factoid, sentiment, toxic, and then both classifiers. They're not here individually, but they are here around anyways. So all of those things will put into one component. So this is another example of what was done last year. Speaking of what is going to happen this year, it might be something like putting some other components into one small annotator and making it available to the public. Or it might be some new skills for the system that could, I don't know, for example, it could be an integration with a home assistant so that people could use DeepPavlov Dream to control their smart home equipment using Home Assistant. It could be also one of the Google Summer of Code projects. So this is the scope, example of scope of things that our New Year's 2022 projects for Google Summer of Code could look like. So yeah, that's about it. Feel free to look into Dream. Feel free to experiment with it. As Dili said before, it's very easy to run it through proxy, so you don't have to have a very powerful machine to run it on your own computer. You can easily chat with it in the command line. And if you want to work with this HTTP API, you can use the DeepPavlov agent documentation where it explains how to interact with the system. And API is very straightforward. I don't know how more straightforward it can be. Yeah, so integration with something like Alexa API could be something like that. Yeah, absolutely. And if you want to talk to Dream, we are hosting it on our cloud. You just go down to DeepPavlov.ai, click on Dream. You have to click that you agree with our disclaimer responsibility, which basically says that we will share the conversation you have with everybody else, because we're trying to assist in collecting open domain conversational AI data sets. And then you can chat with it. And you can say hi to the system. And what you can also do is you can click on more tools and developer tools. And then you can go to the network. And I could say that I had a fantastic day. What about you? And you can see how the interaction actually looks like. There is some sort of debug output that provides you some of the information that the system actually transfers or collects about the conversation. See, here we can see the DeepPavlov friendship skill responded to us. And holy cow, it's quite a possibility that I could write those phrases. Quite a possibility. Dili, do you think I could write something like this, or was it someone else?
This is the friendship skill?
Yep.
What are you asking?
I wondered, do you think it was me who wrote these phrases, or was it someone else?
That's not the main thing, I think. I don't remember.
Okay, so here we can see what's happening actually. So while the bot responded with the text, it obtained lots of annotations. Like this is a combined classification I was talking about using multitask BERT, and it grabs a lot of information like chat intent, dialogue topic, and classifications for factoid emotion and so on. All the data is collected and then we reason upon it. We also have Midas classification, which is a publicly available classifier that we can use to detect dialogue acts. And Midas itself was designed by folks from Gunrock who won Alexa Prize too. And it's quite a useful and relatively high quality classifier that you can use in your own products. And it's available here. It's open source, so you can use it in your systems right now. So you can talk to the system here. You can figure out how it actually works from even just using a web browser and developer tools. You can look into the code. Yeah, I know it's a lot of code here. You can start with very simple variation of Dream. We call it DP. DP is very simple. There is, for example, an example where DP has, I think, maybe even just one skill. Let me check. Maybe I'm wrong, but it might be, yeah. No, it has two skills. Still has two skills. So it has program Y and then it has FAQ skill. And then you can grow up in your understanding of how to build multi-skill AI assistants or skills, or chatbots, and use our entire Dream, which has lots of components. I think at some moment we've got about 100 components in the system in total. So we can see the T5 template skill has port 8120, which says a lot about the complexity of the solution we've built. Yet while the solution looks very complex, it's not really complex because all the components are microservices and you can plug and play them, you know. Like in 90s, there was a saying that Microsoft plug and play was actually plug and pray because you could plug something into the system and the system would just fail. In our case, it's plug and play. You can just put new annotators into the system, and then it's up to you how you can use them as the skills. So, yeah, that's about it. Let us know what you want to work on during the Google Summer of Code, what kind of things you like and don't like in the Power Dream. Let us know what kind of things we could simplify down the road. And stay tuned for the announcement of our projects for Google Summer of Code that will be published in the next few weeks. So if you have any questions, we will be happy to address them. Feel free to write them down right now, or you can always go to our Telegram group and ask your questions right there. Yes, the phrases are really complex. That's because we wrote them. Okay, folks, it's not really that complicated. It's complex, but not complicated. You don't have to grab all of the components to build something easy. So you can easily start with, DP, which is very small. But the thing is, if you want to build your own AI assistant, this is how you can build it. And we have documentation for it. We are running proxy servers for you, and we are giving talks like this one. We have a community chat in Telegram. So basically, we are trying to do our best. We're doing our best in helping you folks to build your own AI assistants. Okay. Okay, so I want to say thanks to all of you who joined our community call today. Stay tuned for more announcements in our group. And I want to say a lot of thanks to Delia for having her with us today, and as well as Oleg, who left, but he was with us earlier today. And I'm looking forward to see what you're going to build with the Power Dream. This was a big dream for us to ship it and to make it available to the general public. It was a fantastic effort of our team, and we shipped it in the end of last December. So we are very anxious to see how you're going to use it. With all that said, thank you so much for joining us today, and see you next time. So stop sharing. Thank you very much for joining. Ishan, Danish, Basaraj. Thank you all, folks.